All right, our next presentation is going to be on the replacement of a cover plate on a non-redundant riveted through girder bridge. And this is going to be by Andy Hall of the New Hampshire DOT.
I'm going to talk to you today about a repair project we did to a through plate girder located in Andover, New Hampshire. This bridge is 24 feet wide. This is that bridge that was in the picture previous. It's a through plate girder. It's 24 feet curb to curb, 70 feet from bearing to bearing. The girders are built up with shapes and plates. The web is the 7/16 inch plates, and the flanges on top and bottom are made up of 6x4 by 3/4 angles, interior and exterior. There's a cover plate on the top and the bottom.
The cover plate on the top is a 7/16 inch by 14 inches that runs the full length of the top of the bridge. And the cover plate on the bottom is also a 7/16 by 14 inch cover plate. And that cover plate on the bottom runs right here on the middle 30 feet of the bottom of the span. So our bridge inspection section did
The bridge inspectors did an inspection in the summer of 2014. They noticed some deterioration on the bottom flanges. They did a rating of what they had found for deterioration, and based on that rating, they said this bridge has critical deterioration in critical section. We need to downpost it to 20 tons and make it one lane, which goes hand in hand at 20 ton immediately. This is on Route 4 in Andover, New Hampshire. It's a fairly significant east-west route in the south central portion of New Hampshire. So there's a fair amount of traffic on this, trucks and cars. So we went out there right away. We put down barrels that you can see in this picture to make it to one lane. We put down temporary traffic signals to keep it one lane at a time, and then we decided what to do from there. Here's a couple of sketches of what the inspectors found. On the picture on the left, you see the bottom flange with the cover plate. Those cover plates were 3/4 of an inch thick, and there was about 1/4 inch of section loss on the interior side of that angle. These through plate girders are notorious for they leak. The snow, salt gets piled up on the curbs. It melts, it leaks down behind the curb along the cover plate, down onto the bottom flange, and starts deteriorating the girder. On the right side of that picture, you can see the section of the bottom flange where there was no cover plate. In that section, the interior angle was almost completely gone. There was some sections where that 3/4 inch angle was now a 1/8 inch thick angle. So the section on the right side of the page, that's what controlled the rating. The area that was the worst was almost at the edge of that cover plate. Here's a picture of the existing cover plate. It looks like a lasagna noodle. It's all pack rusted. This is underneath the bridge, looking out at that inside lower flange. The bridge is all riveted together. It was built in 1933, had never been rebuilt. Here's a picture of the section loss of the lower flange in the critical area. In the bottom of the picture, you can see the cover plate. I'm standing near the abutment of the bridge, looking out toward the center of the span. In this area, you can see that this is after we had needle gunned it, there was hardly anything left of that lower flange angle. The proposed repair that we're given to fix this bridge was to remove that lower cover plate and replace it with a 3/4 inch thick cover plate that was 50 feet long. So basically it's going to be 10 feet longer on either side. And the challenge we had was, well, how do we support this bridge while we do it? Obviously we can't have any live load on it. We're going to have to close the bridge down when we do this. And if we're going to do that, then we've got to get it done as quick as we can, because this is going to really affect traffic. So we looked around, we said, what do we have on hand? Sort of like the Maryland presentation beforehand. We keep some salvaged bridge girders in various locations at our yards around the state. The beams you see here, they're in our yard in Rumney, New Hampshire, which is the middle of the state. This is actually the entire superstructure of a bridge. There's the channels for the diaphragms, the beams. They're all stacked up here in this yard. This was a 76-foot bridge that was built in 1948. Had been replaced at some time since then. We had the beams. So we said, well, we've got these 76-foot bridge girders. They would actually span that cover plate, that through plate girder in Andover. Perhaps we could use these to support the bridge. We weren't sure how we would do that, though. So this picture here is a picture of how they were supporting a bridge down in Portsmouth. They replaced one of our lift bridges. And this is actually a jacking frame that they had on a barge. They would put entire spans of that bridge on the barge and float them out. This kind of gave us the idea for how we could go about supporting our bridge in Andover when we did our repair. Now, obviously, We're not going to get a barge and hold the bridge up. So what we did is, with the design that we had was, we took those 2 support girders and we laid them across the bridge, spanned the entire bridge, and then we hung the bridge off of those girders. In this picture here, these are the support girders right here, and we built a jacking frame, which is all of this here, on top of those support girders that supported the bridge through means of coil rods that ran right down. We drilled holes in the deck, they went right to the deck, and we cradled the floor beams on either side of the center of that bridge, that through-plate girder, with this jacking frame, and then we were able to lift it up and support the girder. This is a elevation view. This here is a cross-section view. You can see here's that floor beam in purple. Here's our 2 support girders we put over the bridge. We're hanging the bridge right off of these coil rods. This out here is the actual through-plate girder that we're going to be replacing. While we were planning this out and getting materials, the crew went out there and they started de-leading the area underneath the lower flange where we're going to be working. So lead paint. So the superintendent of this particular crew used to be a lobsterman, so he has no problem with nautical things. So he built this. He took a bunch of rafts and conglomerated them into this barge we called the SS Fullerton. That was his name. Worked out pretty well. The water here was pretty deep. The bottom was really mucky. His couldn't work off the bottom, so we had to float. So this here is, at the same time we're doing that de-leading, we're getting our plans together, we had ordered some steel to fabricate a new cover plate. The steel comes in 40-foot sections. We needed to make a 50-foot cover plate, so we took 2 pieces of 3/4 by 14-inch flat stock, and we butt welded them together, and we had to straighten them. We had an 1 5/16" warp in the cover plates, and in our fabrication yard in Franklin, we did a heat straightening exercise one day. Doug Gosling, who was our administrator, who's now retired, he led the charge on this, and we got it from 1 5/16 inches of a warp back to 5/8 of an inch. So here we have a picture of our support system. This is the bearing we used for those 2 temporary support girders. You see we're right at the end of the bridge. This is the end of the bridge right here. We're sitting just off of the end of the bridge. We put down a road plate. We have a built-up 12-inch H-pile section, and we're going to do this project, we did 1 girder at a time. So we wanted to get our support system as close to that girder as we could, so we could be as close to the edge of those floor beams we're hanging as we could. So we were able to get this right up against the curb of the bridge. We had to be kind of precise in where we're going to have these because we needed to know where to drill our holes for our rods we're going to hang the bridge off of. And you can see our holes, we're going to end up right on this side of the white line. This is where 1 girder sits. The girder sits here. Those rods are going to hang down in this area. So the day came to close the road and get the girders out there. We had to hire a large crane because we couldn't have that crane on the bridge. So the truck was going to be on the bridge, and also because the bridge was now 20 tons. We had to get a fairly large crane because we had to lift from quite a radius. So what we did is we had the truck back up, had the truck pull up onto the bridge, center himself, and the crane pulled up as close as he could to the end of the bridge, and then he lifted it from there. So he had a radius of about 60 feet operating, so we had to have a 120-ton crane to do this. And one morning, we moved those beams from where they were down to here. We closed the road. We picked up the beams. We put them on their support girders and got to work. And the day that this started was, I believe this was October the 14th. This was October the 14th when this started. So here's just a picture of those support girders in place. You can see they're sitting on the bearing. We have them as close together as we can. They're as tight to the edge of that through-plate girder that we're going to work on. We're going to work on this side first, so we have them as tight as we can to that. You can see when we got the girders in place, the tops of the girders didn't quite line up, and we had to have our jacking system quite plumb, so we did some shimming. Then here's the picture of the jacking apparatus in place. You can see there's a center floor beam in the middle here, and we're 1 floor beam to either side of the center when we picked this thing up. Everything was tack welded in place. The tubing we're using here is 3/8 inch thick 5x7. The jack's going to go right here. It's going to push up on this. We're going to get it to where we want it to be. Then we'll take these nuts here, back them down, tighten the jam nut up, and that'll hold the bridge. These plate washers we had to make for this, they were 1 inch thick. Here's a picture of the underneath, how we held that floor beam. This is those rods coming down to the deck. Here's another of those 5x7 tubes. We had to be within 3 feet 2 inches of the girder, the main girder that holds the bridge up. We were able to be within about 3 feet away from that. This here is a picture of the jacking in progress. We knew that the load we're looking for was around 64,000 pounds on the jacks. We figured that the beam would deflect 2.17 inches, and we figured the deck would come up about 5/8 of an inch. You can see here the string. Put the string in there for a reference mark. The string goes from end to end of the beam. I made a crayon mark, even with the string on the edge of the girder before we started so we could know what could happen. And we just measured off the deck for the position of the deck. The beams deflected about 2 inches. I don't have my notes I wrote down. The deck came up. It did not come up 5/8 of an inch, but we did get it to come up some. Our superintendent didn't believe it'd come up at all. So we got the deck up. We started to take the cover plate off, and then it started to rain. And it rained for a week, just pouring rain. And at some of those points, we had to have our raft run. This is a picture of the raft underneath the scupper. The whole curb didn't leak that bad, but the whole curb certainly leaked. These here, I put this picture in here also to show this system here of these wooden bunks. Once we had the cover plate off, we had to remove it from the bridge, and we had to put the new one down there. We couldn't put anything on the bridge as far as equipment goes. So what the guys did is he built this system of bunks. They're 4x4s, and got the first cover plate, which is, you see here, some of the rivets are removed, dropped it down, slid it out, pulled it over to where they could attach something to it, mechanical, lifted it up, and the new one went in the reverse process. So it rained, and it rained, and it rained, and the river came up, and our raft pretty soon wouldn't fit under the bridge. Kept on raining, and the bridge almost became an island. I'm standing on the bridge, sticking the picture down the road. You can see the water is almost over the road down here. The water was up to about within a foot of the bearings. This area is it's kind of a backwater area, so it does flood. We'd heard this could happen, then it happened while we were there. This is a picture of us putting the new holes in the new cover plate. That we had to match exactly the rivet holes that are in that existing cover plate, so we had to attach it back to the bridge. So what the crew did was they brought our 45-foot flatbed trailer over there, and this white in the background you see here, it was raining, so we built a tent over the thing. So we had electric drills. We took the old cover plate, put it down on top of the new cover plate, centered it all so it was all in the right spot, and we used that old cover plate as a pattern to drill in the new cover plate. The new cover plate's the thicker one you see in the bottom. Now this new cover plate was going to be 10 feet longer than the existing one. So in order to do that, once we got all our holes drilled for the new one, we cut 10 feet off of each end of that old cover plate, slid it down, that pattern in the new cover plate. Then when we got out there, we brought the old cover plate out, the new one out, they slid it up, clamped it in place, and then they drilled upside down from the bottom up to put those new holes in the existing bottom flange of this girder. And it was just, we might as well have grown gills for this job, it rained so much. So when we got that done, we put the bolts in. We used the DTI washers. We started out putting the bolts in from the top and tightening them, but that top angle, it's an older shape. It's not flat, it's got a little bit of taper to it. We figured it was better to put the bolts in this way. That way the DTIs and the heads are on a flatter surface and we get a better idea of what's going on. And we had like 550 bolts to do on this thing, so it was a lot of belt tightening on this. Here's a picture you can see at the end. This is the new cover plate on that girder. And it's opened back up to 2 lanes, and we got the job done in exactly a month. We were opening up the traffic on November the 15th. And is there any questions?
Before you considered those strong backs, did you look at what it would do if you pushed all the traffic to one side, limited it to lightweight trucks, while you did replacement on the other side, like kept the live load away from one girder and took the cover plate off, or would that have failed?
I don't think that would have worked. We want to keep all live load off at once, all together, so we closed the road to do this.
What was the prior inspection? Did anybody look back to the prior inspection, kind of do an assessment of how much section loss was there at that time?
I've looked back to it. There was some section loss going on. I don't know what prompted the rating at this point, but something did.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.